Hi, all. Welcome. Good morning to everyone. We are going to have a talk by Charlotte Hoffman for the Sustainable and Resilient Infrastructure Seminar Series. Unfortunately, before she starts, you'll have to listen to me talk for about a minute and a half about the Tech Hub, but I'll be quick. This is the Risk and Resilience Tech Hub, and specifically, this is the Sustainable and Resilient Infrastructure Seminar Series. That is a mouthful. Broadly speaking, if you're not aware of what the Risk and Resilience Tech Hub does, we are a public-private partnership working across multiple countries. You see them listed here, and we thank all the folks from local government who are here on this call. And we aim to commercialize solutions, reduce barriers to commercialization for new technologies. And specifically here, we're looking at concrete, coastal, and other things that help ameliorate our changing relationship to water and extreme weather. Broadly speaking, we work on next generation concrete, workforce, governance, although it's like trying to do your entire thesis in 3 minutes. We are doing a lot of different things. I'm not going to go into details of all of that, but feel free to reach out to us and I'm happy to tell you. Ultimately, this is going to result in economic development, good jobs, many jobs, thriving startups, resilient economy, resilient infrastructure. It's going to result in stronger national security as well. What are the areas that we're working on? Broadly speaking, the Tech Hub is interested in energy efficient buildings, in coastal defense, and in clean cement. And as you can see, this is an entire ecosystem here, going all the way from into the water to significantly into the land, and the details of the many things that we are interested in doing are here. If this is something of interest, something that you want to support, something that you want to take part, please let us know. The objective of this seminar series specifically is to educate and bring awareness to high TRL technologies so that their adoption can be accelerated. It is to disseminate information on both high and low TRL technologies to increase the TRL. It is to establish connections between the various stakeholders, right? All of you on this call, and to advance startups and technologies that enhance national defense, enhance resilience, all of that for the region, but ultimately for the rest of the United States as well. So these are the rest of the seminars. I'll provide more information about them as the time comes. But for now, and I realize I have an old version of this here, I apologize. Title here is not the title of Charlotte's talk. But Charlotte Hoffman, who leads strategy and innovation at Kind Designs, is going to talk about their living seawall system and how the system restores marine habitats while protecting coastal communities. I don't want to take too much time, so that's all I have. The only thing I'll ask is please be kind enough to introduce yourself in the chat. So say who you are, what you do, and all of that. So Charlotte, all yours.
Thank you for the intro, Prannoy. So nice to see everyone. Thank you so much for joining to learn more about Kind Designs. And like Prannoy said, if you can introduce yourselves, that would also help me to make sure I'm talking about things that are interesting to you. You're obviously here to learn more. So I will just give a little bit of background about myself and then get into it and tell you about Kind Designs. I'm Charlotte Hoffman. I lead strategy and innovation at Kind Designs. It's a broad category, a lot of things, but includes product development, R&D, grant writing, and all of that involves a lot of academic and policy partnerships. Kind Designs got started about 2 years ago with the goal of creating a global scalable solution for sea level rise and climate change. And here, let me actually just share my screen quickly before I keep talking. There we go. Okay, so we got started about 2 years ago with the goal of creating a global scalable solution for climate change, sea level rise, and flooding. And the first things that we looked at were existing solutions of how coastal communities are traditionally combating these issues. And of course, we looked at seawalls being, the first man-made defense between land and sea, typically in a coastal urban environment. And what we found is that seawalls really haven't seen a ton of sustainable innovation since the first modern-ish seawall was installed in the US. So this is the first seawall in the US in Galveston, Texas in 1904 after the Great Storm. This is a wooden seawall. Now we have concrete and steel and vinyl seawalls. But beyond material changes, the actual function of the seawall hasn't changed much. And what we found is that, seawalls all have the same kind of two problems. One is that they reflect wave energy, and so it leads to scour and erosion at the base of the seawall and overtopping of water behind the seawall, which both create structural issues and can potentially lead to premature failure of the seawall. Um, but then two is that they destroy marine habitat. So you're replacing what would be a dynamic coastal ecosystem in South Florida, maybe a mangrove forest, with just a flat wall that can never hold the same amount of biodiversity and life that, a natural coastal ecosystem could. And the White House did a study and they found that within the next 15 years, so 2040, we'll actually be replacing about 50,000 miles of habitat with seawalls. And that's a huge deal because there was actually a University of Miami study that, was looking at seawalls and their impact and found that when you install a seawall, you lose 45% of the biodiversity within 1 year of installation. And that has a compounding effect because as you destabilize the ecosystem, it becomes harder and harder for it to recover. So with the projected seawall construction happening in the next 15 years and obviously continuing after that, and the impact that has on biodiversity, we wanted to create something that could just function, one, as a better seawall structurally and better protect communities, but also that could better protect the environment, since right now seawalls don't seem to be going anywhere. So that's when we came up with living seawalls. What if we can create a seawall that can actually house marine habitats and also provide some more structural benefits than a traditional seawall as well? So here's an example of us 3D printing one of our living seawalls. The method of manufacturing was chosen purely based on what our goals were. 3D printing allows us to create extremely intricate and unique customized designs. We wanted to take a biomimicry approach, again, to mimic what the natural coastline might offer in terms of habitat. So this is an iteration of our mangrove route design for any of our South Florida projects, but bringing our technology to other regions, other states, we can do a totally different design that mimics, that natural coastal environment. So obviously with new technology, a lot of times the hardest thing, even if it's a great idea, is just getting adoption. So we were really focused on how do we get people or just everyone to start using living seawalls and replace all, toxic traditional seawalls with a living seawall. And the way that we thought about doing that was just to fit into the existing like regulatory and permitting environment. Um, so just on kind of the regulation side for seawalls, we obviously looked at the building code and said, okay, what are the specifications and requirements, mainly having to do with the strength of the concrete and rebar placement. And so our seawall, we 3D print the exterior, which you saw in that video. We add rebar in the interior, and then we fill it with traditional ready-mix concrete that all marine contractors use to pour and for a traditional precast concrete seawall. So right away, we can fit in with the existing building code. Again, with 3D printing, it's totally customizable, so we can match the exact dimensions that an engineer specifies for the project. We can change the rebar in the interior to match the project specs. And then the material we're using is also not necessarily novel at all. It's a 3D printed extrudable mortar. It's a 5,000 PSI mix. So at the end of the day, it's quite similar to a traditional seawall. Instead of using wooden formwork to form and pour a precast slab, we kind of create this quote unquote formwork with the 3D printed exterior and then fill that with your, traditional ready mix. So really fitting immediately into the building code so that at least you can permit this project. And then again, on the permitting side, because we fit into the building code, something I'll talk about a little bit more in a second is that in Miami, up until about a month ago, 2 months ago now at this point. It used to take 2 years to get a seawall permit. We actually just passed some legislation that has since changed that to 90 days. But as a company, we're only 2 years old and we have 9 projects in the water. If it takes 2 years to get a permit, how is that even possible? It's because we can customize our product to meet the exact dimensions of plans that have already been permitted without needing a modification. So this is just an example. Obviously, these are some, engineering plans with a lot of words on the screen, but just to show you, on the left side, we have the original permit of our first project that we did in Miami Beach. On the right, it's what the shop drawing that we submitted. Since they're both concrete, it was a one-to-one swap, just a plug-and-play solution. And the homeowner didn't need to apply for a new permit to install this. So we installed this seawall literally just 4 months after we got our first robot. And then lastly, again, to help with adoption, we needed to make sure that installation was exactly the same. The marine contractors having buy into our product is hugely important because at the end of the day, you typically, buy a seawall from a marine contractor, but now you'd be buying it from us and they would be doing the installation. So we really wanted to make the marine contractor's life easier, one, by just making the panels ourselves. Right now, it takes a long time to get a concrete seawall because, just the manufacturing process being horizontal versus vertical just limits how many panels you can make at a time, especially if you're forming and pouring panels on site. There's typically not a lot of room if it's, not a commercial or government project to actually pour panels on site. And then you have to let them cure for, 28 days. But with us, we can actually just 3D print this wall in, just an hour for a 10 by 10 foot seawall panel, which is your typical size in Miami-Dade County, and then fill it 24 hours later. So we have enabled contractors to actually complete a lot more projects because there's not as much waiting time to actually precast these panels. But then again, on the installation side, it's the same exact installation as a traditional precast concrete seawall. They don't need to get any special equipment to be able to install our precast concrete or our 3D printed living seawalls. And you can use the same exact installation methods, king and batter piles, tiebacks, dead man anchors, helical anchors. So again, really just making it as easy as possible for people to adopt this solution without needing to necessarily change regulation, even though we also did that. So here's just an example of a project being installed. This was our first project in Broward County. This is in Fort Lauderdale. We actually presented to the Marine Advisory Board, and one of the women at the meeting needed a new seawall. So this happened like about 8 months later, which is awesome. Another project is our first project in Miami Beach. You can see here. So the other part of adoption is obviously with new technology, proving that it works. And so that's where academic partnerships have been extremely valuable to us. So we've done a lot of work with UM and with FIU. Here you can see photos from monitoring that we've done, and this was all with FIU, with Alistair Harborn, who's on the call, and PhD student Emily Jackson, who have done an amazing job diving at 3 of our walls every single month, and taking amazing footage of the sites and fish that are in the area. So just on the design side, how do we actually attract more species? One, we have, the microhabitat, which is the rugosity created by the 3D printing process. So we create all these textures that you don't get on a normal, smooth, flat seawall, whether that's concrete, vinyl, or steel. And so just that texture allows organisms to actually anchor onto the wall, which you can really see on this photo. Kind of at 12 months, we have sponges, mussels, and oysters growing here. But then two is the macro habitat, which is the biomimicry design that I talked about. In South Florida, we're doing this mangrove root design. And this is really where you see the biodiversity impact, because now you don't just have, species that can attach the wall, but you have organisms further up the food chain that can actually live in the wall. So here you can see the mangrove roots touch, but there's actually a cave behind it, which Emily Jackson captured in this photo here of this sea urchin. And so Alistair and Emily have actually found lobster, crabs, juvenile fish using this as like a safe hiding spot, which was obviously you can never accomplish with a flat wall. So those two things actually also double the surface area. So not only are you creating space for marine life to attach, you're actually doubling the amount of space that could for marine organisms. And so the impact of that is obviously increased biodiversity, improved water quality with all these filter feeders on the wall. But then it's also wave dissipation. So that's kind of where the structural part comes in as well. So a flat wall will actually reflect nearly 100% of the wave energy. We sent our walls to the University of Miami's Sustain Wave Tank and worked with Dr. Brian House, who is the director of the wave tank. And we did some tests kind of mimicking waves that you would normally find in Miami and, in the intercoastal, in the open bay, wind and wave wakes, and simulated these conditions with a scaled down version of our walls and found that, on average, we were able to dissipate about 45% of the wave energy. And that was kind of with our most conservative design. So we can change the size of the mangrove roots, again, 3D printing, customizable. So we sent, our smallest mangrove root design, which is only 4 inches. It's barely anything. But even with just that 4 inches of roots and texture, we were able to have a really big impact. And so now we're working together to actually refine that design even more so we can improve those results. And actually part of that refinement has, we won a NAVC SBIR, so a federal grant to work with the Navy. And we've been working with the Naval Research Laboratory, who redid this testing and was actually really interested in our seawalls, not just for the ability to dissipate wave energy, but because that means you could potentially reduce sea spray aerosols, which would also reduce atmospheric corrosion, which can be a huge problem at a military base. So we've been doing some testing with them, and we're really excited to kind of debut some new designs in the coming months that wouldn't have been possible without working with University of Miami, Naval Research Lab, and FIU. Oh, sorry, repeat photo, guys. Okay, so I'll just leave this up here, but with all these benefits, we have been able to actually kind of change legislation and having proof of these benefits with our academic partners. So how I talked about, traditional seawalls reflecting wave energy and destroying marine habitat, you typically have to then mitigate for your seawall on top of paying for the seawall itself because of those negative consequences. Because our seawalls incorporate, the benefits that you don't traditionally get, we have actually been able to change legislation to say that if you have a living seawall that meets this, X, Y, and Z criteria, you actually don't need to mitigate for your seawall. So that turns into huge cost savings. Right now, we're priced, surface level, we're price competitive with a traditional seawall. Now, living seawalls are actually much cheaper than a traditional seawall because you don't need to pay for that mitigation. Mitigation is usually in the form of riprap rocks, which you can see in this photo. So this was before the legislation passed. And these rocks end up being, based on Miami-Dade County requirements, you have to have about a cubic yard of riprap for every linear foot of seawall. And it ends up being about $40,000 for a 100-foot seawall. And our panels are actually less than that for 100 feet of seawall. So we've been able to save homeowners a lot of money and also now encourage people to choose a seawall that could function better for their property and for the environment over a more harmful traditional seawall solution. So it's obviously exciting for everyone involved in the coastal space that wants to see, improvements in our marine ecosystem and protecting our marine ecosystem. Then the other things I just want to highlight are other products I want to highlight just mainly because of the partnerships, and I want to emphasize how important that has been to us, is our kind tiles. So these were designed specifically to retrofit an existing seawall and invented for this specific project at Bayfront Park in the town of Longboat Key, so on the west coast of Florida. These are to cover a vinyl seawall. Sarasota Bay Estuary Program did a study. It was, I believe, an unpublished study, but they were monitoring oyster colonization before and after they installed this vinyl seawall, and they found that it kind of decreased by about 80% after the vinyl seawall was installed because nothing could actually attach to that wall. And so they put out this solicitation or RFP asking for a solution to their vinyl seawall without having to replace it because it was so new that could help encourage oyster growth. So these were installed actually just about 2 weeks ago. We partnered with Kearns Construction, a marine contractor, and Cummins Cedarburg, an amazing coastal engineer, and Sarasota Bay Estuary Program to create tiles that could retrofit this existing seawall. For this project, we also ended up going kind of with a mangrove root design. They wanted something super natural. But again, with 3D printing, there's always the possibility to do something a little bit more custom. And here is kind of the finished installation. You can't even tell now that there was a vinyl wall. So it looks amazing, and I think it turned out really well. It's super exciting. And then the other partnership I want to highlight is just actually, this is our first project outside of Florida. This is in New York. We partnered with Billion Oyster Project, but our pilots in Florida and the Florida regulators being so open to this new product is really what has made our expansion possible. So we're so grateful for that. Billion Oyster Project is one of the large oyster nonprofits in New York, and they have a goal of deploying 1 billion oysters by 2035, have deployed many different types of oyster reef structures. But as that 2035 date gets nearer and nearer, they're looking ways to set more oysters on a single structure without increasing size, and something that could really fit into their tanks and their current deployment methods. So we worked with them to create this custom oyster reef solution, which we're super excited about. At this bottom photo, it's really hard to tell, but all those little darker brown spots are oyster larvae settling on the oyster reef. And they saw amazing setting equal to that or greater of their other structures, but they were able to customize this, work with us to customize this structure so that it could easily fit in their tanks, match kind of the dimensions of things they've already had permitted in the past, again, making it really easy for you to permit like an oyster reef structure or a living shoreline structure, which can be notoriously challenging. So that was another really exciting partnership, and has also, opens the door for us in the New York market, working with trusted partners. And so here you can just see kind of, because we're creating the solution that can fit within the existing frameworks for coastal resilience and coastal construction, and kind of are meeting the needs of what mitigation is trying to do, we've been able to get these incentives of, regulators, but also other agencies encouraging this type of solution. So LEED v5 talks a lot about increasing biodiversity and resilience and climate resilience. WEDGE is another certification, similar to LEED, but is specifically about coastal design and waterfronts. And so we can help contribute to some of those points. And then Miami-Dade County, we have the 100% riprap reduction. In Broward County, we're working on that right now. The Fort Lauderdale project is our first kind of pilot, which I'm really excited for Alistair and Emily to also be monitoring that project. And then we have some cities and towns that are actually giving permit discounts for this type of solution, as they're, trying to encourage more living seawall, living shoreline type solutions to protect our amazing Biscayne Bay. And this is kind of the team. Just want to highlight Anya Freeman, the founder, since she's the brainchild of Kind Designs, an amazing leader. And she actually got started as a lawyer. She had a very different life before Kind Designs, but pivoted just because she saw the need for her home, Miami, to have more solutions for coastal resilience. That's it. Thank you guys so much. Please let me know if you have any questions.
Thank you very much. Let me stop the recording.